Hello, this is the fourth video of the second order differential equations series 1 on homogeneous equations for OCR Pure Core Further Mathematics. And we will look at finding particular solutions given boundary conditions for those second order differential equations. In the previous video we found the particular solution using initial conditions, two pieces of information, allowed us to identify the arbitrary constants a and b for the general solution or complementary function y equals ae to the m1x plus be to the m2x. Boundary conditions are when the information is given for the same different values of the independent variable. For example, y equals 0 when x equals 0 and y equals 2 when x equals 1. Then the problem is called a boundary value problem. Using the same example as in previous videos, d2y by dx squared plus 2 dy by dx minus 15y equals 0, and boundary conditions that y equals 0 when x equals 0 and y equals 2 when x equals 1, we're substituting in those values. So when x equals 0, we would have that 0 equaled a plus b, and when x equals 1, we have that 2 equals a e to the 3 plus b e to the minus 5. So again, we have two simultaneous equations in two unknowns, and we can see from the first equation that a will be the negative of b. So we can rewrite that second equation as 2 equals a e to the 3 minus e to the minus 5. A then equals 2 e to the 3 minus e to the minus 5 to the minus 1. And if we multiply top and bottom by e to the 5, we can then write that as 2e to the 5 over e to the 8 minus 1. And b will thus be equal to minus 2e to the 5 over e to the 8 minus 1. If we use these values in the general solution, we will then have the particular solution, as shown at the bottom of this slide. If we were to graph this solution, we would see that the curve passes through 0, 0 and 1, 2 as expected, as shown by the blue and red dots on the graph. In the next video, we consider the case where the auxiliary equation has repeated roots.